Well, hey there, it's your old pal, Mr. Cook. We just finished up the second page of the review. Now we're going to move on to the third page. So the third page starts off by saying, write a possible equation for the given graph. Use sine and cosine. Okay, so I guess we have to use both different ones. That's not a big deal. So let's see. It looks like on the very first, on the first inspection of this graph, it looks like it starts at a maximum, and then it goes to a minimum, and then a maximum again. That's the cosine graph. So if it starts at a maximum, that's easiest to just use cosine. So that's how we'll start it off. Y equals, and then, cosine of something. All right, next. It looks like it's up by 2 to the maximum and down by 2 to the minimum. So that means that the central line is at 0. So that means that there is no vertical shift, so plus 0 at the end. And then it goes up by 2 and down by 2. So that also tells you the amplitude. So since it goes up by 2 and down by 2, that gives you the number that's out in front, 2, for the amplitude. And then the last part is we just got to figure out what the period's going to be for this stuff, right? Because it doesn't have a phase shift at all. So the period is how we're going to put this thing together. All right, so here we go. Ready? We got to go from, it looks like 0 all the way over to pi for one full period. So here's how you do that. You start off with theta, and then the distance between these two is 0 and pi. And we need to make it like this. We need to make it go from 0 to 2 pi for a full period of this graph. So how do we do that? Well, the missing ingredient is this. So if I multiply anything by 0, I still get 0. What do I have to multiply pi by to get the 2 pi? I got to multiply it by 2, right? So if I multiply the middle part by 2, and this part by 2, and this part by 2, I end up with 0 and 2 pi, right? So 2 theta, is going to be that middle value right over there, 2 theta. So it's kind of backwards engineering the period model that I used before to do this. Okay, so there you go. That's all you have to do for it. So now let's go ahead and see what we would do if we wanted to make this a sine graph instead. So sine graphs start at the bottom, and then it goes up to the top and then down again. So let's start it right over here. So this is one sine graph going from 0, or the center line, down to the bottom and then up to the middle again. That's one full sine rotation, one period of sine. So here's what we're going to do. We're going to start it off right there and go all the way to here. Okay. All right. So we've got y equals sine of some stuff. Let's see what we need to do to fill it out. Well, first off, sine is still centered around 0, so there's no vertical shift, so plus 0 again. And then, the tallest part and the lowest part goes up and down by 2, so 2 is still the amplitude. Now let's put together the period from the information that we know. Well, it looks like the sine graph is going to start right over here, which is halfway between pi over 2 and also pi, which is 3 pi over 4. So 3 pi fourths, would be where it would start. And then it would end, the sine graph would end right over here, which it looks like it's going to be, it's halfway between 3 pi halves and then also 2 pi halves. So that's 1.5 pi and 2 pi, so it'd be 1.75 pi, which would be 7 pi over 4. All right, so again, my goal is to turn this into 0 and also 2 pi. So the first thing I got to do is turn that into, I got to turn this side into a 0. So what I'm going to do is subtract 3 pi fourths from both sides. So if I did that, let me move these down a little bit. That's going to be my target to turn it into that. So the first thing I'm going to do is move that subtract 3 pi fourths to get 0. So if I subtract 3 pi fourths from both sides, I get 0. And then I get theta minus 3 pi fourths. And then I get 7 pi fourths, also minus 0, or minus 3 pi fourths, sorry. Okay, and then if I do that real quick, 7 minus 3 is 4. So that turns into 4 pi fourths. And, do I need to do anything more with that, right? Because 4 pi fourths, if I just reduce that, that's just pi. Okay, so I'm at a good spot now. Now, all I need to do is make, the 0 into a 0 and the pi into a 2 pi. So what do? I multiply everything by 2 again, right? So I do 2 times all of this stuff. And then 2 times that stuff. And 2 times that stuff, 0. Well, 2 times 0 is just going to be 0. And there we go. We've got 0 and 2 pi. So that means that this is going to be our inside part of the sine function. So 2 parentheses theta minus 3 pi over 4. And that should do it. And you can graph it out to show that it's the same exact graph if you want. It will be. All right, there we go. Let me clear off a little space because I might need that for the next one. Okay, the next one says, an oblique triangle has side lengths of 8, 7, and 13. Find the measure of all of the angles. Yeah, that's easy, I think, right? Like, let's verify that we will get a triangle from this. So if I take, all right, what is it? It's that all of the side, like if I take any two sides and add them together, they should be larger than the third side for all the different combinations. And, you know, if you do that, 8 plus 7, that's 15. That's more than 13. 7 plus 13 is 20. That's greater than 8. And then 8 and 13 is 21, and that's greater than 7. So yeah, it looks like all of those are going to make a triangle, so that's good. So then when we put together the triangle, it looks like this. So we've got 13 and 7 and 8. So to find the measure of all the angles, we just use the law of cosines. I don't know how you were taught the law of cosines, but here's how I was taught how to do it. You know, you pick a side, and often you want to start with the largest side. And then, you know, you pick the angle that's across from it. We'll call it theta. And then to solve for theta, we use the law of cosines. And it's given to you in your formula sheet. You just got to kind of know how to use it. So here's the law of cosines right here. So what it says is that if you want to find, oh, wait, actually, it's going to be, it's the angle. So if you want to find some angle, then you've got to know the sides that are across from it, that'd be A, and the sides that are adjacent to it, that'd be B and C. So here's how I like to write it out. It's like if you're looking for an angle, it's equal to the cosine inverse of, and then B and C are the different sides that are around the angle. So like if I have on my triangle, you know, this is angle A or whatever, I need these two sides here and here, side 1 and side 2, if I want to get the side across from it, X, okay? And vice versa. If I have all three of these sides, I pick the side that's across from the angle to tell me what the angle's measurement is, okay? So the angle is going to be equal to the cosine inverse of the two sides that are around the angle. I square them and add them together. And then I subtract away the side that's across from the angle. And then I divide that by 2 times each of the sides multiplied together. So, you know, that seems kind of like ridiculous, but law of cosine is actually really, really easy to use. It's just the formula. You just type it into your calculator, essentially, to get the measurement. And I'm assuming that the measurement of the angles is going to be in terms of degrees. So we're going to put this in degree mode before we do it. Anyways, all right, so we're going to start with the side length 13. That's going to be across from some angle measurement. So one of the angle measurements is going to be like this. So angle number 1, it's going to be equal to the cosine inverse, and I'm just using the formula from before, cosine, in the law of cosines. It's going to be the two sides that are around it, so 8 squared and 7 squared, minus the side that's across from it squared, all over 2 times the sides that are around it multiplied together. So if I just type that in my calculator, I'm going to get some angle measurement. I got to make sure that I put this first in degree mode. Oops. Come on, there we go. Okay, and then cosine inverse of, and then it's going to be a fraction. So let's see, alpha y equals fraction. There we go. And then it's going to be 8 squared plus 7 squared. Oops, that's inverse, darn it. There we go. Minus 13 squared all over, and then it'd be 2 times 8 times 7. Okay, and there we go. There's our answer. So it's 120 degrees. Wow, that's it, really? 120 degrees? That seems a little bit odd. Cosine inverse of that in degree mode. Yeah, okay, so 120 degrees on the dot. That's crazy. Is this rounded or something? It just seems like a really odd value to get. Yeah, I guess it must work out okay. Cosine inverse, 8 squared plus 7 squared minus 13 squared over there. Okay, well, whatever. I'm like fixating on it, but it's just 120. Okay, and then the next one that we would do would be 8. So we just changed the numbers up a little bit. So basically, like what we would do is we'd say that the next angle, angle number 2, is equal to, and then we do cosine inverse of, and then we do the same thing. But now, okay, so on the triangle, now if we're looking for the side length, if we're using the angle across from 8, we'll call that angle number 2. Then the sides that are around it are now 7 and 13. So we do the exact same pattern as before, but 8 is basically going to be here. We just basically trade the 13 and the 8s in this example. Okay, so it becomes 13 squared plus 7 squared minus 8 squared all over 2 times 13 times 7. And then that'll give us another angle measurement. Let's see what this angle measurement's going to be. Okay, let's see here. So cosine inverse of, and then, I did the fraction thing before. That was a nice trick, but I just realized that not everybody can do that. So I'm going to show you another example of this without using the little fraction thing on my calculator. So you've got to make sure that you group together the numerator and the denominator. So make a second set of parentheses and do the numerator first. So 13 squared and then plus 7 squared minus 8 squared parentheses. So that's the top part, divided by parentheses 2 times 13 and then times 7. Okay, there we go. We get an angle measurement of 32.204. Let's round it to 3 decimal places. So 32.204. There we go. Okay, and then if we have 2 of the angle measurements, then we can find the third angle measurement really easily, because all the angles inside of a triangle add up to 180. So angle number 3 is going to be equal to 180 minus 120, and then minus our last angle, 32.204. And, just type it into your calculator. Let's see what we get. So 180 minus that number, 120, and then minus the other number, that one. So 27.796. degrees. Okay, so then we have all of our angle measurements, and maybe if it's multiple choice, it's like you'd have those angle measurements in in some order. Okay, solve each triangle and round your answer to the nearest tenth. Yeah, no problem. So they want us to find all the missing sides and all the missing angles on all these. Let me think. Yeah, I'll do all of them. This might be a little bit longer video, so I'm sorry if it's like that. But I'll get through number 16. Even on this one. So let's see here. Here we go. So we have to decide if we're going to use law of sines or law of cosines. And here's how you can tell if you're going to be able to use law of sines. Because I always kind of decide if I can use law of sines. If I can, then I'll use it. If not, I'm going to use law of cosines. Because you can always, these problems are structured in such a way that you'll be able to use one method or the other. So with number 15, part 1, I notice that I've got an angle and then 2 sides that are around it. So I would know that I have to use law of cosines, and here's why. It's because I only have one angle measurement, and I can't get the side that's across from it. Okay, I don't know what it is. So if that's the case, then you can't use the law of sines, because you need from the law of sines. Let me bring it up on the formula sheet. You always need one of these ratios. You need one of the sides over one of the angles. You need one of them. If you don't have that pairing, you won't be able to solve it, because it's always set up as a proportion. And if you have too many unknown values on a proportion, you'll never be able to solve for one individual value. So that's kind of the reasoning behind it. Now, I can use law of cosines here, and this is going to be really, really easy to use. So I'm going to use the other law of cosines, the one that solves for the side lengths. That's this one right here. And I'm just going to type it in exactly as it is. So basically, if I want the side that's across from the angle A, here's the formula that I would use. Okay, so let's see how this looks. So I'm going to solve for this side here. Let's call it x. So x is going to be equal to the square root of, and then we do the 2 sides that are around the angle. We square them and add them together. It doesn't matter which order you put them in. And then you subtract away 2 times each of those sides multiplied together times the cosine of the angle that's between them, which is 119 degrees. And obviously make sure that you're in degree mode when you do this. and then I'll get my little side length that I'm missing. So let's see what we do when we get it on our calculator. Okay, here we go. So square root of, and then it's going to be 22 squared plus 26 squared minus 2 times 22 times 26 times the cosine of 119. Enter. There we go. So that we got our missing side length, and that's going to be 41.408, let's say. So 41.408 miles. Okay, so there's the first part. And once you have that new side, you can use either law of cosines or law of sines. It's up to you. Because you do have the freedom to do that. Now you have the side and the angle that's across from it. So we haven't done any law of sines yet. So let's, it looks like we're going to be doing a lot of law of cosines next. So let's just practice a little bit of law of sines right now. So what I would do is, since I have an angle and a side across from it, I go the angle, the sine of the angle over its opposite side is going to be equal to the sine of another angle over its opposite side. So let's use this side, 26. The angle that's across from it is angle B. So it's going to be the sine of the angle B over its opposite side, which is 26. So then we just use simple algebra to solve this. To get B by itself, what I would do is I multiply both sides by 26. So 26 times the sine of 119 over 41.408. Or you can think about it like this. It's like it's a fraction equal to another fraction, so you can like cross multiply. This actually would work, as well. So, multiplying by 26 also does the trick, and that'll give you a sine of B. And then to get B by itself, you have to undo the sine, which is sine inverse on both sides. So the last step is I need to do the sine inverse of this stuff, 26 times the sine of 119 all over 41.408. And that'll give me my angle B. All right, so I just use my calculator for that. Sine inverse of, and then it's going to be 26 times the sine of 119 divided by 41 point, that number, whatever that is. Okay. And, there's the angle measurement that I get. So angle B is right about equal to 33.31 degrees. Well, let's do 3 decimal places. Well, it says nearest 10, so 31.3 degrees. All right, so that's my angle B, 31.3 degrees. Oops, 31.3 degrees. And again, since I have a triangle, I've got 1, 2 of the angles. Now I can find the third one by just subtracting from 180. So 180 minus 119, and then minus the number that I just got, 31.3. Let's see what that's going to end up being on our calculator. So 180 minus 119 minus the number that I just got. Oops, not that, darn it. 80 minus 119 minus that number. All right, there's what I got, 27.7 about. And that's the last little number that goes right over here. So there's all my angle measurements. And here's a quick way to make sure that you got all the right stuff. There's this rule that you learn in geometry that says that the largest angle is going to be across from the largest side. The smallest angle is across from the smallest side. Is that true? The smallest angle across from the smallest side, yes. Largest angle across from the largest side, yes. So everything's going to work out there. All right, there's the first one. Now the next one is just going to be a bunch of law of cosines. So let me clear out a little bit of space here and get these answers. Okay, so I've got all the sides. I need all the angles. So you start off with the largest side and find the largest angle that's going to be across from it. Now, since I don't have any angles, I obviously can't make a side and angle pair. So I can't use the law of sines. So I've got to use the law of cosines for this first one. And, I'll use the one that solves for the angle measurements. So let's solve for angle C. So angle C is going to be equal to, and then it's going to be the cosine inverse of, and I'm just using the formula that's on the formula sheet. The sides that are around the angles, they're going to be squared and added together. So 27 squared and 19 squared. Subtracting away the side across from it squared, so minus 30 squared, all over 2 times 27 times 19, the sides that are around the angle. And then I'll get my first angle measurement. Let's see what angle C is going to be on my calculator. So cosine inverse of 27 squared, so parentheses, 27 squared plus 19 squared minus 30 squared divided by parentheses 2 times 27 times 19. There we go. So I get my first angle measurement, 79.3 degrees. All right, and that's angle C. Then I go to the next biggest side, which would be 27, and I find the angle that's across from it, which would be B. So B, I would also use law of cosines because law of cosines is pretty easy. So I do the sides that are around the angle, which is going to be 30 and 19. They're going to be squared and added together. And then I subtract away the side across from it squared, divided by 2 times the sides that are around it. And then I just type it into my calculator, and that'll give me my next angle measurement. And then to find the last angle, angle A, I'm going to take 180, and then I'm going to subtract away, because 180 is all the angles added together. So if I find 2 of them, I just subtract those 2 angle measurements away, and that'll give me my total. So let's see what this missing angle B is first, and then we'll kind of wrap it up. Let's see what we got. Cosine inverse of 30 squared, oops, almost made a mistake there, parentheses, 30 squared plus 19 squared minus 27 squared, parentheses, divided by parentheses 2 times 30 times 19. Enter. There we go. There's my other angle measurement, 62.2 degrees. All right, so 62.2 goes there. And now if I subtract all that stuff, let's see what I get for angle A. So 180 minus 79.3 minus 62.2. And here's what I get, 38.5 degrees. So that's the missing angle measurement right there, 38.5 degrees. Okay, that's all 3 of them. Now let's go over to number 15. So number 15, I just need to find one thing. This one doesn't have to solve the triangle, it just find one thing, and that's angle B. Okay, no problem. So I've got a side and an angle pairing, so I can use the law of sines. And that's exactly what I'm going to use to solve for the angle across from the side that I do have. So I do the sine of 71 degrees divided by its side that's across from it, 31 miles. And then that's going to be equal to the ratio of the angle that I'm looking for, the sine of B, over its opposite side, which is 24. So to get B out by itself, what I do is I multiply both sides by 24 first. And then to get the B all by itself, what I would do is I'd undo the sine part, which is sine inverse. So what I need to do is use my calculator and find sine inverse of 24 times the sine of 71 over 31. And that'll be my B value. All right, so let's see what that's going to be on my calculator. So sine inverse, 24 times the sine of 71 divided by 31. All right, so it looks like I get an angle measurement of 47.055. So let's say 47.1 degrees. Okay, that's the only thing that we had to find. Now let's find the measurement of angle C. So it looks like we've got this angle and this side across, so we can use the law of sines to find this, and we can use this side to find the angle that's across from it, angle C. So we set up our ratio, the sine of 115 over its opposite side, which is going to be 43, is equal to the sine of the angle that we're looking for, C, over its opposite side, which is 33. So once again, I would just cross multiply. So I'd multiply the 33 over essentially. So that would give me 33 times the sine of 115 over 43. That's equal to the sine of C. And then to get C all by itself is, what I would do is take the sine inverse of both sides. So the sine inverse of this stuff. And then the sine inverse of the sine cancels out, giving me just C. So let's see what that, simplifies to, or is approximately equal to. So we do sine inverse of, and then it's going to be 33 times the sine of 115 divided by 43. And that's what I get, 44.1 degrees. That should be it for that one. All right, that was a lot of work. Gosh, sorry this video is dragging on so long. Number 16. So if the sine of an angle A in the third quadrant is equal to negative 3/5 and cosine of B is in the fourth quadrant and it's 12/13ths, what is the sine plus B, A plus B, and then the cosine of A minus B? So these ones come directly from some identities that you guys learned about, the addition and subtraction, and the sum and difference identities. So we're going to be using this formula for A plus B. And then we're going to be using this one for A minus B. Okay, so let me write them down. So that's going to be sine, and then it's going to be sine cosine plus cosine sine. All right, so it's going to be the sine of A times the cosine of B plus, because you have a little plus there, the cosine of A times the sine of B. So that's the identity that I'm going to be using. And then for cosine of A minus B, it's going to be, this is equal to the cosine of A times the cosine of B, and then plus the sine of A times the sine of B. All right, here we go. Let's put this thing together. Well, it says if the sine of the angle A in the third quadrant is equal to negative 3/5, then it already tells me something. The sine of A is negative 3/5. So like sine of A, every time I see that, like, here and here, I know that negative 3/5 is going to go in there. And then the other thing is that the cosine of the angle B, cosine of angle B is, 12/13. So cosine of B, that's this, is 12/13. And cosine of B is this. Okay, so we've already got like part of this, right? Sine of A is negative 3/5. Cosine of B is 12/13. Then we got to find two more ratios, the cosine of A and the sine of B. And we're going to be able to find that, really shortly. And then same thing, we don't know what cosine of A is, but we do know what cosine of B is. Cosine of B is going to be equal to 12/13. And then the sine of A, we do know that, that's negative 3/5. And the sine of B, we don't know what that is yet, so we're going to have to find that in a second. Okay, so let's find what those missing ratios are going to be off to the side. So let's concentrate on angle A first. Angle A is in the third quadrant. So if I know where the third quadrant is, it's down here. That makes a right triangle. So here's my reference angle for angle A. And it tells me that the sine of that angle is negative 3/5. So sine is the opposite side over the hypotenuse. And then if I use Pythagorean theorem, I can find that last little missing side on this right triangle. This is a 3, 4, 5 right triangle, so 4 goes here. And since it's pointing to the left, that's going to be a negative 4. So this is going to allow me to find, since this is the reference angle A, I can find the cosine of A. The cosine of A is going to be equal to the adjacent side, which is negative 4, over the hypotenuse, which is 5. So cosine of A, that's this guy here, cosine of A, is negative 4/5. So I'm going to plug in a negative 4/5 for this, and negative 4/5 over here. Now I got to find the sine of B. Well, it tells me that the cosine of B is in the fourth quadrant. So the fourth quadrant is the one that's like lower right. Okay, so here's my angle B, and it says cosine is 12/13. So cosine is the adjacent side over the hypotenuse, and this is part of a 5, 12, 13 right triangle. So this side would be 5, but since it's pointing downwards, it's a negative 5. Okay, so if I need to find the sine of the angle B, it's going to be pretty easy, right? It's the opposite side, negative 5 over the hypotenuse, so negative 5 over 13. So that's the last thing that I put in here, negative 5 over 13. Now you can, spend your time multiplying all these fractions together and simplifying it and stuff. You can probably get it done pretty quickly. I'm just going to do it on my calculator, though. I hope you don't mind. Just, to make sure I get it right and all that stuff. So negative 3 over 5 and times 12 over 13 plus, and then we've got a negative 4 over 5 times negative 5 over 13. Okay, and I get some number, and then I'll just do math frac and see what that's going to be. Negative 16 over 75. 65, sorry. Okay, let's do the same thing with this one. Just plug it in and, change it to a fraction again. Negative 4/5 times 12 over 13 plus negative 3 over 5 times negative 5 over 13. Okay, and then change it back to a fraction. Negative 33 over 65. All right, there we go. Okay, that concludes the next video number 3. That was a doozy. Looks like the rest of this is going to be pretty easy. That's all matrices and stuff, vectors. I could probably do the next 2 pages kind of in one video. Well, we'll see. Okay, that's the end of this one. Thanks for sticking around. If you have questions, make sure to ask your teacher. I'm going to start recording the next one. See you later. Bye-bye.